Hey guys, this is Mr. Gron. This is 7.4 Properties of Logarithms. In this video, we'll be expanding and condensing logarithmic expressions. So the first property we're looking at is the product property. There's two forms with the product property that are equivalents of one another. One is in this form. This is what's known as the condensed form, meaning that it's condensed into a single logarithm. So if we have log base b of m times n, a product, we could rewrite that in its expanded form like this: log base b of m plus log base b of n. Now, where this comes from is the exponent properties. So if you think of your exponent properties, what would you do if we had x squared times x cubed? You would add the exponents together. That would be equal to x to the 2 plus 3, which is equal to 5. That's where this comes from, because the log base b of mn refers to the exponent that gets you from b to the product m times n. Okay, so what are we actually going to do with this? If you see something like this where it says expand the following, you are given the condensed form of a logarithm. You are going to apply the product property to give us the expanded form. So all we have to do, we have a product here of 2 times x. So we're going to split the 2 and the x apart. This is going to become log base 3 of 2 plus log base 3 of x. Now, condensing is just doing the same thing except in reverse. So we're going from the expanded form to the condensed form. So we're going to take the two things that are being added here and we're going to make them a product over here. All right, so log base 7 of 6 plus log base 7 of x, that is going to become a single logarithm of 6 times x. All right, our second property is the quotient property. And again, we have a condensed form and an expanded form. The condensed form being a single logarithm, which is a quotient, a fraction. And the expanded form now looks like this, where it is a subtraction, where it's the top of the fraction minus the bottom of the fraction. The m is on the positive side and it's subtracting the n. All right, so where this comes from again is the exponent properties. What we would do if we had x to the 5th over x squared, for example, is we would subtract those exponents. It would be equal to x to the 5 minus 2. And that's really where this property comes from. Okay, so what you're going to be doing with it, again, expanding, we're going from the condensed form to the expanded form. Anything on top is going to be the positive, and we're going to subtract anything from the bottom. So this will split into two logarithms for the two terms, log base 5 of 4, the numerator, minus log base 5 of x, like that. And then condensing is just going the opposite direction. Anything positive is going to be on the top of the fraction. Anything negative is going to be on the bottom of the fraction. So this is going to be log base 5 over 10. And on something like this, the fraction 5 over 10, we can reduce that. So I would expect most of us would answer this as log of 1/2. All right, at this point, if you want to pause the video and try a couple of mixed examples, unpause when you are ready. All right, so condensing the following. Anything that has a subtraction in it, right, is going to be the quotient property. So the positive part, the u, is going to be the top of the fraction, and the minus part, it's minus log base 7, so that minus log base 7 of v, so that v is going to go on the bottom of the fraction. So anything positive, the positive log, that part goes to the top. The minus log, that part goes to the bottom. And we rewrite it as a single log. All right, with the other one, now they're both positive. So that means it's going to be a product property. This is going to be log base 3 of the product a times b. All right, expanding, we're just doing that in reverse. Again, it's going to be the top part minus the bottom part for the fractions. So log base 5 of 6 minus log base 5 of 7. And then If it's just a multiplication, they're both positive then, so it's a plus in between them. So this would be log of A plus log of B, splitting it into two logs for the two terms A and B. All right, applying multiple properties. So these problems are a little bit bigger. When it comes to these, now we've got 3 logs here, we've got 4 terms here. Anything positive is going to be on the top of the fraction, so the x and the y. Anything negative is going to be on the bottom of the fraction. So one way to think about this is just take whatever your positive logs are, and those are going to go on top. So this will be log base 3. The fraction is going to have x, y on top, and then anything that is a minus is going to go to the bottom. So z will go to the bottom. Same thing here. Now with this one, a lot of times students, as soon as they see the minus, they put everything on the bottom after the minus, but this log base 4 of d is a plus, so that the lowercase d should go on the top of the fraction. So if I think about what are my positive logs, it's those two. So the top of the fraction will be a d, and then the negative logs, b and c, those go to the bottom. All right, expanding, a little simpler because we can just kind of keep things in order, just pluses for everything on top and minus for anything on the bottom. So in this case, it's natural log now, so ln of 2 plus natural log of y, and then the x gets a minus. So we've split it. We have 3 terms here, a 2, a y, and an x, so we have 3 logarithms in our expanded form. Same thing here. We've got 3 terms, an x, a 5, and a y. We're going to split all of them apart. The x is the positive one, so let's put that first. And then the 5 and the y are minuses because they are on the bottom of the fraction, so we'll put those second. Like that.